The purpose of this video is to extend our discussion of the prism and talk about volume and how we can compute volume for any prism. First of all, what is volume? Volume, simply put, is the space that a figure occupies. You may remember that volume is measured in cubic units and is sometimes written as units to the third power. Formulas that we're going to use to compute the volume of a prism is volume is equal to the area of the base times the height. And that's why it's important that you are able to differentiate the base of the prism from its height. And those were some vocabulary terms we talked about in the first video on prisms. All right, let's not waste any time. Let's go right in and take a look at an example. Number 1 says find the volume of a right triangular prism with an altitude of 6 centimeters if the base is a right triangle with legs of lengths 4 and 8. So the first thing I want to do, because they don't give me one, is I want to get a fairly accurate picture of what my prism in this particular instance looks like. So they tell me that the base is a right triangle whose legs measure 4 and 8. So the first thing that I'm going to do is go ahead and I'm going to start by drawing a couple of right triangles. And this is how I draw my prisms. You are probably going to be able to draw much nicer prisms than I do because I'm not very artistically inclined. But this way we'll get the job done. So I'm going to start with one right triangle for my first base, a second right triangle for my second base, and then I'm simply going to connect the pairs of corresponding vertices. So now information that they give me in the problem that I can label in my picture now is that the legs of this right triangle that make up the base measure 4 centimeters and 8 centimeters. So I'm going to go ahead and label those. I also know that the altitude of this prism is equal to 6 centimeters. Now altitude, remember from the video yesterday, is the distance between the two bases. So altitude is going to be this distance right here or this distance right here that connects my two right triangles, and that altitude is 6. If I think about what the formula is now for computing the volume of my prism, volume is equal to capital B, where capital B stands for area of the base, times the height of the prism. So I really need to know two things in order to be able to successfully calculate the volume of this prism. I need to know, first of all, how to find the area of its base. Well, the base is a right triangle, so I'm really looking first to find the area of that right triangle that makes up the bases. So area of a right triangle is 1/2 times the base of the triangle times the height of the triangle. In this case, the base and height of my triangle are 4 and 8. Together they form that right angle. So 1/2 times 4 times 8, or half of 32, which is 16 square centimeters. So the area of my right triangular base is 16. The volume is going to be equal to that 16 times the height of my prism. The height of my prism is going to be the distance between the two right triangular bases, or in other words, 6. So getting my calculator out and multiplying the 16 times the 6, I end up with 96. And I can either leave that as centimeters to the third power, or if I prefer, I can say 96 cubic centimeters. It's all a matter of personal preference. Those are two different ways of saying the exact same idea. All right, number 2 says the volume of the rectangular prism below is equal to 600 cubic feet. They want us to find the total surface area of the prism. So I'm going to start out with what it is that we know. We know that the volume of that prism is 600 cubic feet. I also know that in order to find the volume of a prism, I'm going to multiply the area of the base times the height. But in this particular instance, my base, you could think about any one of these as being your base. My base is actually a rectangle, and that's where the formula volume equals length times width times height comes from for that rectangular prism. So just because it's going to be a little bit simpler in this particular case, I'm going to use that formula volume equals length times width times height. Now, as for what we know in this particular example, We know that the volume is 6,000 cubic feet, so I'm going to go ahead and plug that number into our formula. We know our length and our width are 30 and 20, and I'm going to think about that x as being the height of my prism. Now you could have used the 30, the 20, and the x interchangeably for any of the length, width, and height. Well, we end up with 6,000 is equal to 600 times x, and when I divide both sides by 600, I find that the value of x is 10, and that's going to be measured in feet. So now I've got a rectangular prism that measures 10 by 30 by 20, and they want us to, at this point, find the total surface area of that prism. So our total surface area is going to include the areas of the front and the back, the areas of the left and right, as well as the areas of the top and bottom. So you can really start anywhere you want. I'm going to start with the front and the back side of the box. So the area here is going to be length times width or base times height, whatever you prefer, or 30 times 10, which is 300 square feet. The right side of my box, which is the same as the left side of the box, that too is going to be base times height, which in this case is going to be 30 times 20, giving us 600 square feet for the right side of the box. And the top of the box and the bottom of the box are going to be the same. Their area also, length times width, their base times height, and that's going to be 10 times 20, or in other words, 200 square feet. So our total surface area for this particular prism is going to be the front plus the back, or 2 times 300, plus the right plus the left, or 2 times 600, plus the top plus the bottom, plus 2 times 200. And when I get my calculator out and plug that all into my calculator, I'm going to give you a minute to go ahead and plug that into your calculator. Now hopefully when all was said and done and you plugged that into your calculator, you ended up with 2,200 either square feet or feet squared. We're talking area here, so our dimensions are going to be in square units. All right, I'm going to go ahead and flip my paper up to the top of the next page, and let's take a look at example 3. Number 3 says, find the volume of the right trapezoidal prism shown below. So this question too asks us about volume. I'm going to remember my formula for finding the volume of any prism. Volume is equal to the area of the base times the height. Because the name of this prism is a trapezoidal prism, I know that the base is going to be in the shape of a trapezoid. So my first mission is to find the area of that trapezoid, which comprises the two bases. So formula for the area of a trapezoid. Remember, this is really just a fancy formula for base times height. Because the two bases in a trapezoid are different, I'm going to take those two bases and average them together. So base 1 plus base 2 divided by 2 times the height of the trapezoid. So in looking at this prism, the two bases of my trapezoid are the 5 at the top and the 11 at the bottom. And remember that in this particular case, the height refers to the height of the trapezoid, not the height of the prism. So the height of the trapezoid is going to be the distance between the two bases in the trapezoid, or that 6 right there. This too I'm either going to do a little bit of mental math with, or I'm going to go ahead and plug that into my calculator. So I end up with 48 square inches for the area of that base. So the volume now is going to be the area of that trapezoid, which makes up the two bases, 48, times the height of the trapezoid. The height of the trapezoid, remember, is the distance between its two congruent and parallel bases, or in this particular case, the distance between the two trapezoids. So the distance between the two trapezoids, or the height of our prism, is going to be 3. So volume now is equal to that 48 times 3, or 144 cubic inches, or inches to the third power. But again, very important that you know how to find the area of that trapezoidal base, and then just multiply that times the height in order to find the volume of that prism. All right, this last question I stole from a Regents exam a few years back. It says, Tim has a rectangular prism whose length is 10 centimeters, whose width is 2 centimeters, and whose height is unknown. He needs to build a second rectangular prism with a length of 5 centimeters and the same height as the original. And they want us, or they tell us, that the volume of the two prisms is the same, and they want us to find the width of the new prism. So because we have two rectangular prisms, I'm going to go ahead and start by drawing these two rectangular prisms. I'm going to go ahead and begin by drawing the rectangular bases. I'm going to connect the corresponding vertices, and that'll give me a nice little 3D looking figure. Now I'm going to say that this blue one is the original one. Its length is 10 centimeters. Its width is 2. And its height, the distance between these two bases, is unknown. So I'm going to be not real original and call the height, the distance between those two bases, is h. I'm going to start out by drawing a second now rectangular prism. This is going to be my new, or Tim's new prism. And in this prism, they tell us some more information. In the second one, they say the length is going to be 5 centimeters. The width, we really don't know. We're going to call it W. But they do tell us that the height is going to be the same as the original. Now I called the height h in my original, so I'm also going to call my height h in the new one. I know that I can find the volume of any rectangular prism simply by multiplying length times width times height. We want the volume of the original blue prism to be the same exact volume as in the new purple prism. So in other words, I know that when I multiply length times width times height of the old blue prism, I need that to be the same as length times width times height of my new purple prism. Well, my length, width, and height of the blue prism were 10 times 2 times h. My length, width, and height of the purple prism are 5 times w times h. And here we have kind of a dilemma because we've got two variables in this question, which makes it feel a little bit uncomfortable. This isn't going to be so ugly as we move along. If I think about simplifying the left-hand side, I've got 20 times h. And when I simplify the right-hand side as much as I possibly can, I've got 5 times w times h. I'm seeing an h on both sides. Since I know that the height of my prism can't be 0, I'm going to go ahead and divide both sides by h. And when I do that, I find that 20 is equal to 5 times the width of our prism, making the width of our prism here equal to 4. And the dimensions that were given to us here in this question, I think were centimeters, but I'm going to go back, double checking just to make sure. Yes, it was. So we want the width, or Tim wants the width of this new prism to be equal to 4 centimeters. All right, so we're at the end of the video on volume of a prism. If at this point you have questions, I'd like for you to jot them down at the bottom of this page so that you don't forget about them and you can remember to ask them when you come to class. Or even better still, shoot me a quick email so that when you come into class, I'm prepared to answer your questions.